So, yeah. Oh, yeah. A few words on JSON. JSON you're very comfortable with, so I will really... Let's see. JSON I've really brushed over it because you guys are very comfortable with this, but it's just good to highlight the contrast and keep it kind of comparable, right? So JSON is kind of standardized since 1999, so also quite old actually. Not as old as XML, but still. And standardized by ECMA. Who the heck is ECMA?
ECMAScript.
Yeah, what is that?
It was before JavaScript. It was called ECMAScript.
Yeah, so that's right. So it was originally called ECMAScript, and I think the standardization is still done by ECMA as of now, right? So they call it a specific variant of JavaScript, ECMAScript, and they have introduced that. So it comes actually from the programming domain, clearly, right? Not just machine readability, not just transmission, not just document representation, not just interoperability. It strictly comes out of the JavaScript community, right? So, and it was centered really about providing a super lightweight format, not that having this baggage that we see, still human readable, machine readable, of course, and with the intent to represent objects, because that was a challenge, right? We have web applications in which we are now able, thanks to JavaScript, to work on objects or whatever that was at that time. Let's see, key value structure. And exchange those across different machines. So that's the key value. Literally the key value. Yeah. Right. So what kind of structures do we support? Well, you know it anyway, right? So we either have some sort of arrays, right? So representation of lists, if you like, that in which values can be combined, and we have the idea of having some sort of collections, right? So you're representing the idea of a map structure where we have a string-based key and some sort of value as a value. It actually quite needs visualization from the specification page there. And there we have different support for different types, some of them anyway. What is here? We have string, we have numbers, we have objects. So you notice number is just number, right? So it's not particularly strongly typed, very weakly typed. We have an array, and then we have Booleans that can be specified along with the null value as well. So quite neat. What are strings looking like? So it's literally specified this way, quite straightforward. Well, you know, there's quite some stuff you can use. Most of the Unicode characters, but there are some exceptions you shouldn't use. You can also specify special characters, for example, such as my line feeding. I just you just saw on my screen. So new line, form feed, backspace, and so on. So classical special characters can be considered, but without certain control characters. So yeah. Number formats similarly specified. So what do we have? Well, it can be positive, negative, have 0 to 9, and a multifold of those, and they can have decimal places, and they can have exponent specifications, either positive or negative, again with an arbitrary number of digits. That's roughly what JSON is about. So the idea is really to be super lean, and I think that is quite successful. So if we take an example here, employer information consists of employees. Employees have a name and an age apparently, and then that's how they are listed, right? So quite lean and straightforward. If we compare this to XML, just for the sake of it, just to get a feel, well, one of the claims that was here made earlier kind of holds. It looks like a bit more data, right? So, and it's quite straightforward. Why? Well, there's a lot of redundancy, right? So both in terms of the text, of course, well, mostly in terms of the text, right? Be it on the aggregate level, also on the individual element level there that we have, right? So much about JSON. I don't want to go into that again because you guys are. That's literally what's there to JSON. It's not much more. Thoughts? XML with JSON. No? One is better. Which one?
JSON.
JSON still? Yeah. Good. JSON is lean, right? Isn't it? I kind of pushed it a bit by having this very brief rush over it, admittedly. Sell it a bit more trendy and fashionable. So, well, it's about advantages and disadvantages, right? What are the advantages of either? Please, yeah.
I think one of the big advantages of JSON is that it's you usually have a better overview of the structure if you know how the structure is supposed to be.
Yeah, cool. Yeah, it's one position.
You can very easily parse it in programming languages.
That is
have
true.
a lot more support for JSON.
I'm not sure a lot more, but there's definitely a lot of support, yes. So, because, I mean, most programming languages have some XML parsers probably hidden away in the meantime a bit. The overview thing, that's an interesting one. I just don't know, I mean, because it's a highly subjective, I find it highly subjective. The reason is mostly that if the complexity rises here, I'm sometimes not sure whether this gives me more information, because if you imagine this consisting of multiple elements embedded in there and a large number of entries, it probably, I don't know, you could lose overviews in which particular element you're currently working in. I don't know. I think that's a bit subjective. I see your point there, but I think with increasing complexity and nestedness, it could be challenging. Please.
One advantage XML has is it usually comes parsed with new lines, and I don't think JSON does when you receive the data.
Ah, I see. Well, yeah. That's another point here. But it's generally concession to the efficiency, right? So that you minify JSON when you transmit it, because you don't want to waste time on this. You're right. I think in many respects in XML, while internally it's often done as well, but people kind of give up because that final character really doesn't make a difference anymore, right? So given that that's awesome. So well, what I'm going to get at is basically sure, JSON is in principle looks more efficient as a data format, right? So there's no doubt there. Both have a validation or some sort of well-formedness check, right? So your parser will tell you whether you get JSON that's not well-formed, right? You quickly notice. Same for XML, right? So well-formedness is given, but JSON doesn't by default have schema support, right? So that's one of the downsides. So if you have a reasonably complex structure, then you don't have the mechanism of specifying the schema outright, and certainly not in a. Well, we get to that. Generally not in a program language independent way, right? Again, as I mentioned before, that the schema specification is part of the XML specification itself, meaning it's agnostic about the programming language, right? And in JSON, of course, we have validators, but they're oftentimes specific to a programming language, right? So it would imply, okay, you need to use better this particular JavaScript framework to have schema assessment. But so it's yeah. Another aspect is typing, right? So apart from the complexity of data structures, data types that are supported in JavaScript as opposed to in XML are weaker, right? So, but we know that anyway from the language, but it translates well into JSON as well, right? So we have fairly weakly typed data. So for some cases, this is simply not enough, right? You want to be much more explicit about the typing structure, and then that's also a decision point when you can think about, okay, do I need something richer such as XML? And again, we don't have the meta annotations as explicitly, but there's the issue, especially with respect to the schema, is recognized, and there are some moves into actually introducing schemas, and this is literally work in progress. Like, this is not like solved yet, right? So it's actually work in progress. And one of those initiatives is called JSONschema.org. The idea is to put JSON schema forth for as an RFC with the IETF, right? So as a request for comment. So it's like a proper internet standard. It's not yet, so it's currently an IETF draft. It means it's informational and has been submitted in September 2019. And the idea is that those drafts are in work in progress, and if they are not. If there's no progress on those, they expire. They expire after 6 months. Basically, it's non-standard again. So it's kind of to promote the birth phase, so people don't just put out a draft and leave it there sitting, but actually to force them to continue working on it to make it a proper standard, right? So that's the latest one. They now named it no longer draft 5, 6, 7, 8, 9, but rather they call it now based on the follow the practice of encoding the year and so on and month. And what does it do? Well, it basically tries to emulate most of the XML features or the XML schema features and embedding them for JSON. We see that example here. so that we can have condition specifications such as in this particular location there needs to be one off, right? Either a integer value or a string value, for example, right? In order to present this to the user, there's also a title associated with this that could present, oh, you're missing a integer value or a string value, right? And that's then the associated type from internal point of view, how it's supposed to be represented. And so on. The idea is also to have things like defining elements. So here's quite an interesting one. Actually, defining a positive integer. So what is a positive integer? As specified by the schema, positive integer is a number of type integer, but with the exclusive minimum of 0, right? Those kind of activities are done. So how can we develop those constraints is basically the question, because to overcome the weak typing and the relatively poor specification of semantics or cardinalities or options and so on. Just some examples. This thing is highly work in progress, so I mean there may be a lot of things being thrown over and still changing, right? So, but it discusses a lot of stuff. If you want to have a look at it, it's probably worthwhile browsing it under jasonschema.org. There's a link, pretty much on the main page, to the current IFC that I proposed. It defines a lot of those keywords that are then of course used as well, like the schema, vocabulary, notion of IDs, anchors, references. So all the kind of stuff we already have in XML, for example, basically is specified there, right? So, but it also discusses semantics in more depth. What does equality mean, right? When are two things equal, basically, right? So all the conditions for which it will hold or not. Notion of inheritance, something like this, right? Can we represent inheritance? Meaning, if you specify something in a super element and not in a sub element, will it apply in the sub element? Aspects like that are managed, because that's basically anything goes right now, right? You just take it as your document comes in, but what actually means the semantics are really weak in terms of specification. Assertions, right? So very important, of course, for a validation point of view, which assertions we make. And various schema types. So it's like more simple schemas, more complex schemas. So that can also be user supplied, and that's some of the ideas that are coming out of there. Just to give you a bit more of a substantive view, without going into depth into any of this, really, to just show you an example of a. That's a nice website that kind of does a reasonably good job, I think, in terms of highlighting those latest features. In terms of a validator. So to close my email thing, because yeah, for example here, right? So if you have a particular JSON, the idea is that it can infer the actual schema as per current draft, right? So that would be the idea. So you can literally type any sort of valid JSON in there, and you can infer the schema, and it will infer the schema for you, and you can also go to the here to the specification and say which version of the schema you're referring to, because supposedly it's still changing, right? So it's also important to know that. But the JSON schema.net lets you do it. So if you have, for example, a very simple, straightforward entity with some let's not look at the schema, let's look at the example. Entity has some sort of dimensions, apparently is not checked, an identifier name and a price, and so on, further text. This would be then, according to this, basically the schema specifications, right? So it basically says, okay, what is required, what are seemingly required elements, so there's no indication of optionality anyway right now because it's all there. What are the properties of checked? Evidently, it's a Boolean, right? So that is to be inferred. The default value seems to be false, and a valid, currently known examples are false. For example, dimensions can apparently consist of a width and a height, both of which are required. So it's a nested structure, and the widths are specified here. Is an integer as far as the specification goes, and the height is here. So you can see how that kind of builds up basically throughout this process. So fairly similar in a way, but slightly different notation. But it aims to capture all the same features that we know in XML. So there's some perspective on the horizon that may actually become more relevant. And then it's also more accessible for you to specify schemas and actually assess them properly. Those tools will probably be the main driver for driving schema development. I think the menu design is probably far less likely anyway, so it would be very cheap for you to specify schemas as well. The other thing I just want to highlight is in terms of standardization efforts, and if you like, it's JSON API. The idea is that it's not so much looking at schema, meaning like layout of data structures, but really about layout of APIs, right? Something you do actually do yourself. So the ones of you who took cloud, for example, there was a lot of challenge about how to design an API, right? So what are the elements to include, what are kind of default paths you want to have, and so on. And there are some initiatives that I suggest, okay, instead of doing it all on your own, which you of course can, why don't we have some sort of standards that help us to devise the layout of APIs properly, right? So, and in a uniform manner. And JSON API was intending to do that, always intending to do this. This thing is actually stable since 2015. I'm not sure how the adoption really is, but the idea, it makes certain assumptions about the server and client-side representation. It standardizes the request and response structure, particularly with respect to, for example, relationships, right? So how do you represent relationships in a document or in a request or response? Instead of brewing your own and assuming that this is a relationship to something else, you actually make it explicit in that kind of way, for example, right? So if we have an article, then we have relationships of this particular article, which is a separate element which contains the author, which has including a link or a related link, and of course the data that is associated with the relationship with respect to an identifier. So look under people for identifier 9, that's the author. So kind of a similar intent in a way, but for a slightly different purpose, right? So it's really about more request response formats, how that should be laid out. So really for the interaction with web services still. And emphasize the idea, kind of the key purposes there, of course, higher standardization gives you much better debuggability, right? If you really run your own payload and so on, it's sometimes quite hard to figure out what went wrong, what went right, and so on. But by allowing for this standardization, it's easier to debug. That's basically the main essence. Cool. All right. Just pointer there. So nothing, you probably would want to look at it. I'll provide the slides anyway. So just have a browse and see what you think. But there's, it's just more awareness than anything else. So I think one of the essence that I want to get across here, it's not necessarily always about the better format, right? It's really about format suitability. What do you actually want to do, right? So you write a web service. Do you want to provide a document and so on, or a complex structure? Is it about just object representation? Of course, the choice is obvious, right? How important is validation, right? So, because we don't even know if validation will be a thing in the long. I mean, it probably will, but you know, we don't know when and so on. The validation for JSON is sufficiently finalized and stable, right? How complex the data types? Do you need annotations? You know, do you need meta data in the widest sense? How important is, of course, performance from a payload point of view? And the other one is also on a practical side, and that's what you're hooking onto. But what's the purpose of the API, right? Is the API just to be used, or is the API your product, right? So do you actually want people to use your API to enhance their products, or is it just to interact with you in the first place, right? If it's, for example, for sending the API as a product, yeah, there are trend factors, right? So then you guys are back in the game and saying, yeah, you know, it just looks more modern if you use JSON as opposed to XML. That could be a relevant factor. If it's about reliability of the interaction, it may not be the decisive factor. So, but it's important to bear in mind. And the last one is, of course, which programming language do you use, which systems do you use, and how is their respective support for JSON XML? That should be an important point, right? If you use legacy systems and you have interoperability challenges, they may not be JSON supported in the first place, or your data structures require so rigid specification of strong typing, for example, that you don't want to afford using JSON, because you always need to fix it in the back anyway, because you basically need to check whether your typing commits to the strict requirements that you have. Well, you know, so that's trade-offs. So basically, there's no, as far as I'm concerned, what I get across here is give you a nuanced, bit more of a nuanced overview of both systems, and you then need to decide which is better, depending on the application, not in general. It's just apples and pears to some extent. Okay, one other format, just briefly go over it, and the reason why I put it at the end is probably because it's the youngest one. As I mentioned, I presented in rough order, 2001, current version for 2009, so also a young dinosaur already. So it has been around for 10 years, you know, so that's not super young. And it was originally called, does anyone know what it originally was called in expanded version? YAML? Why did they use this acronym? It's not anymore, but it was. Kind of reflects a bit of irony, but also the fact that they're a newcomer to the game. So it was originally they tagged themselves as yet another markup language. So, but it became the actual name of it. It's not supposed to be used in that way anymore. I read it on top actually. I should read my own slides sometimes. But literally it was the name at that time. So here the idea is. This is really data-oriented as opposed to representing a complete document structure necessarily. So it doesn't have all those rigid requirements. And the idea was to have a sensible, the purpose was to have a sensible compromise. So be more efficient than XML because we saw the inefficiency based on the opening and closing tags and so on, but still retaining most of the feature set and certainly more than we have in JSON. And the use is largely in areas of configuration, right? So you find it in DevOps and sysadmin areas, but also in programming. To some extent, Docker and Ansible are quite known for using those YAML files. And they have a bit of a, if you see them, some of you may not have seen before, but this is a Docker script, for example. Some have seen that. And they have a bit of a, which programming language does it remind you of to some extent? Python, right? Super Python-esque, because that's precisely what they do. So they don't have the elements, the tags anymore as we have in XML. They don't even have braces anymore, like we have in JSON. So even that is cut away. But instead they deal with indentation, right? So that's a substitute. So does that explain why it's used in configuration files then? And if so, why? Why is it attractive for configuration files? This format.
Because configuration files are mostly key value pairs.
Yeah, number one, number two, yeah. Did anyone work in an industrial environment where different people configure things? If not, you're lucky. Because one of the things is it forces you to have a fixed layout, right? So it's not so much the big schema or whatever else, but the layout is fixed. So it's incredibly readable, this stuff, right? If you know a Docker file, right, you look at the Ansible file, you kind of will understand that thing from the get-go, right? And not, oh yeah, sure, my SQL password starts here, and then the database starts here somewhere, right? So basically, all the kind of formatting ambiguity, so you use tabs, spaces for formatting, all that kind of is solved for you and ensures guaranteed readability, the indentation level signal, ordering, right? So this is a content of the DB, this is a content of the container WordPress and whatever else, right? The volumes are listed here and so on. So it's incredibly clear and readable. That's one of the key strengths. That's why it's so popular in configuration files. You kind of can't get it wrong because you're forced into the convention if you work in a shared environment. So from a Colab point of view, that's really, really nice stuff. But fundamentally, you mentioned before, it has the same feature of the key value differentiation. So in this slide, very similar to what we know from JSON, by retaining the reference to nested structures, for example, right? It allows for enumerations, has extensible data types, so it has base data types, but you can also extend them and refine them to some extent. It has the relational aspects to it. For example, here, WordPress depends on DB, right? So we have those references that we retain. Yeah, so in some other aspects, strings don't have quotation marks and whatever else. So sometimes collections are order preserving, that's nice as well. So if you have collections, they keep the order. you can specify this as well. So that's much, much richer than the flexibility you have in JSON. Please.
I've done some YAML, but the problem I always have is indenting.
Yeah.
But even on this one, we see that the DB entry has 3 spaces indented, while image has 2 spaces indented.
Yeah, that's already off, isn't it? Yes.
So is there like does it matter or?
That's the standard indentation having the. That's true actually. Why do we have 3 spaces in DB? I did spot that one. That's a good point. But the double indentation is basically the standard. I'm not sure why Docker is so lenient on this one and tolerating this. But yeah, you're right. It's not 100% accurate. I'm with you on this one. Well, evidently it doesn't matter for this particular application, right? Because still the validation is still part of the implementation itself. I don't think it comes with an explicit validator in its own right. Again, right? So it's a bit of a weakness there. But I need to follow up on this. It's a good point. I haven't spotted this. In fact, very good. Talking about just to fill up some gaps on the features as opposed to over JSON, perhaps, is the kind of duck typing approach to data. You can do some type hitting here. So if you have, so you see you have considerable stronger flexibility that you actually have here, right? So even if it's not quite clear, you can actually indicate, that's supposed to be a float, even though we don't have a decimal place at this particular stage. So it's stronger than JSON, not just allowing you to represent a number, if you like. Cool. Yeah, it also has a kind of built-in commentary, which is kind of useful. That's good. Yeah. So I mean, it's kind of what I want to get across with YAML is pretty much like a middle ground in one way or another. So it's kind of efficient, like JSON, richer than JSON in terms of the typing and its flexibility and the complex structure, representation, commenting, and so on. But compared to XML, it's way leaner, retains many of the features. What it doesn't retain is text, for example. It's a bit of a pity. And it still doesn't have the explicit validation support that we expect, so it always relies on third party. There are some out there, but it's not really part of the standard in its own right? So that's a bit of a pity there. Of course, efficiency is higher and it's partially convertible into, there are tools for this purpose as well, into XML. So I really run out of time. It's a bit of a pity. So we have 3 formats there. How do I do this? All those formats, yeah, I'll probably talk briefly about some of BSON on Protobuf, then we go from there, because I wanted to talk a bit about performance. Probably I'll do it next time. So now we saw pretty much data formats that are used for document specification or data specification in a wider sense, XML, YAML, and JSON. So for different purposes. But efficiency is a concern, right, for all those. That's a classical problem. And there are different approaches about how to attack this. And this could be interesting for you to explore, for example, in your group project to some extent. And I just want to highlight 2 initiatives that are really quite visible and you kind of at least want to know about. Doesn't necessarily to mean that you deal with them. Because all the formats that we have right now, you guys mentioned at the beginning, have the downside that they are human readable. And that means that they are probably not optimized for machine readability. One of them is binary JSON. First one, you want to notice here. So the idea is basically that is a binary variant of JSON. So basically the idea is not only, but in fact you compress whatever you express in JSON in the first place in order to make the payload small to go over the wire. Doing this, it's not only a binary format, but it's actually a superset of JSON features. It has new data formats that allow you to already store binary data within JSON itself, so make it even more efficient, right? So the transcoding in this particular case needs to happen. It has an explicit data type as well, for example. a binary representation of MD5, like a hash function and so on, and a representation of doubles, which is not part of the JSON standard itself. Because then it's easier to compress if you know have known formats basically. Strongly aligned with C data types. So basically that's the idea. Usually, very likely you won't really be able to read it properly anyway, and the work is largely done for you by libraries. The sort port is relatively wide in terms of the output, and largely automated for you anyway, apart from perhaps specifying the additional features if you need them in your libraries. So that's briefly on binary JSON. I just want to also highlight before we run out of time, a Protobuf, the other one. This was born out of an initiative by Google itself. So Google has the problem that it has a large number of diverse systems, not just JSON-based interaction, and not just object-style formats, but rather complex formats in a way. But XML is not an option, too slow. JSON is not an option, too simple, no validation, all that kind of jazz. And they need something that's really reasonably fast and accommodates a diversity of different layouts and so on. But on the other hand, there should be this rigidity of having an high-level specification. So they kind of another aspect was also the expectation that this was so focused on performance that there was a continuous progression in terms of specification. It means that it needs to retain backward compatibility, right? So this standard should actually just move forward, but retain compatibility to all over it. And then, of course, needs to have large number of language bindings, which Google ensured in two ways. Number one, by having a diverse set of in-house systems, which it evidently supported, but more importantly, by making this public, Protobuf, right? So the community could actually sponsor additional bindings. And it was initially actually developed since 2001, so it's a bit of a old approach as well. But it was only released in 2008 publicly. So and that's where it gained some visibility. You may have come across it perhaps. And how does it work? Well, here it's more so. Unlike having a fixed format, such as in JSON, right? We know the data types, we know the elements, and you can offload the heavy lifting to libraries largely. In Protobuf, it's slightly different in a sense that you think about the messages you want to send. So you think about the data structures you want to send. So much more data-oriented focus here, efficiency focus. That you, for example, say, which syntax do we use? That's an. By the way, it's specified as an IDL. What's an IDL? By intention, you can spell that out. It's a nice exam question.
Independent.
Nearly, yeah.
Data.
You find it quite often. Comes across. You will come across again. Interface definition language. Basically, it's an abstract language to define interfaces, right? So, which is often specific to particular problems, right? For example, in Android, for inter-process communication, you specify the interfaces in AIDA, Android Interface Definition Language. Right? They're always different. It's not the same thing all the time, but their purpose is clear, that they're abstracting from the programming language, but describing the interface. And the Protobuf one is this one here. And the idea is there. Well, we can have different meshes types. That's actually taken from Wikipedia even. It's quite straightforward. That's why it's so nice to think about it. That you represent, for example, a point. Well, guess what? Point consists of x and y coordinate, a line that has a start, end, and possibly a label. And then we see pretty much all the features that are necessary for baseline specification. Compulsory nature or optional nature of something. And of course the elements that are contained for a particular message type. The interesting thing is that you specify the index of the particular field within a particular message, because once translated to message bindings, all this is removed, and just the reference, the order in which the elements appear, delimited in the particular message, is relevant, right? So there's no explicit representation of label X and Y in the payload itself, because that's all pruned away for efficiency purposes. But to do that, you specify the index in which order those items occur in any payload message. Basically, that's the idea, just to get the feel why they're doing this way, right? So the first element in the line message would be always a start element, the second one always an end, the third one always a label. And that can be easily mapped on both sides. But you see already that both sides really clearly need to commit in their respective language bindings and implementation to this idea. Based on those ones, the idea is then to create stubs, or also generate stubs using so-called Protoc. That comes up with something like this here. So and then it can be easily embedded into your actual code. In this case, C++, for example, if you create a new line, it creates the accessors and mutators for you, right? The setters and getters of that and so on. And it also respects the notion of collections. For example, here a polyline is a repeated point, basically. It's a collection of points, actually, right? So, and this is also accommodated in the generation of the stub that we see here, right? So we have initial points, second points, and then we add points to a polyline to build it up and so on. But this is basically totally language specific, in this case C++. So just the feel of what you're dealing with. So while it sounds scary, it's actually quite lean in its approach as well, right? So it can be really efficient, and of course the format is highly illegible, but you see how you can approach developing it. But it's quite cool in terms of its features, and that was one of the things that Google needed. You have a fairly strong typing, again, quite in contrast to JSON / therefore BSON. The collection structures are on par, I would say, but you have the representation of cardinalities or list of repetition of fields, and you have further validation options that can describe constraints, both on values but also on options for selection options that are allowable, for example. So it's quite a bit of features that are supported as part of this. In fact, there's quite a number of different serialization formats out there, so it can't hurt to have some sort of idea. Not that we require it in any way, but just to raise the awareness. Not the stuff I'm talking about is not all the stuff that's out there, but there's quite a bit more that is quite relevant. So and they all come out usually out of proprietary initiatives initially that are often made open source and expanded to community, because they realize quite quickly, guess what? If you want to popularize a format that is for interoperability, I think people need to be able to access and use it, right? Otherwise, that's going to be staying in-house and just die on its own. And there's quite a number of those, right? So this comes from ASN1 comes from a telecommunications sector originally. Afro is now managed by Apache. I think it came from a private company before. It was also about efficiency. We find BSON here, which is, that's right, heavily used by MongoDB for the interaction, which is quite natural, but you don't feel any of that because you just think you interact in terms of JSON. It does the heavy lifting for you there. Comma separated values, you mentioned that before. That's one efficient format as well. This is like, I don't know. This is so. There is literally a IFC on this one, how it should be well specified, but realistically, CSV is so broadly and widely used, and delimiters are so erratic. It's tricky. One downside here, of course, is it assumes a reasonably rigid format, right? So, and also, it's not good for, not necessarily optimal for sparse representation, because then you have a lot of delimiters you need to be dealing with. So, so there's quite a lot of stuff there. XML again, flat buffers from Google as well. It's an alternative pathway. Doing Java serialization, so that is proprietary, but native to Java. It works quite well as long as you interact based in Java, right? So you see the interoperability challenges that are involved there, JSON of course, and so on. So it's kind of a mix of human readability and non-readability. Protobuf, big one. So I think that's quite neat really to be aware of. So more theoretical S expressions, how do you represent functions, for example, particularly in Lisp or in functional languages. But it's kind of really all over the map. But Protobuf is really, I think, something that's quite worthwhile. You find a lot of features here as well in terms of what they are, where they're specified, if they're human readability, whether they're human readable, and whether they support, again, IDLs, right? So meaning, is there an independent or programming language independent specification language that hopefully can help you generate stubs for your programming languages? One thing you actually want to look out for is how broadly supported they are, right? So before you pick a highly optimized format, figure out that they are supported by more than one programming language, right? So that's often the trade-off you're really facing there. In addition to human readability, it's the support by languages, and I can't overemphasize this. It's quite important. So there has been a lot of initiatives. Oh yeah, Thrift. That was created by Facebook first. Similar objective than Protobuf, also efficiency for interaction. And then Facebook had a similar challenge that let's go public with this thing. And they put it public, I think, in 2007. I'm not sure how actively you're still using it. It's, as far as I understand, not as efficient as Protobuf as well. But we may actually look at this. But YAML is here as well. So quite a bit of formats, just to be aware. That's the ones that we discussed are, of course, not the only ones, but I think they're the most relevant ones that you want to keep an eye on with respect to that. I think I'll leave it at this for now. Originally, I want to talk a bit about more performance. Perhaps we can sneak that in the next session if you're interested. But for now, I'll leave it at this. So I think I bombarded enough with the different formats. But it's good if you can reflect on them and bear them in mind. Get a feel of what those formats are about, what they're good for, what they're not good for. Because again, as professional programmers, you're not only in the task to program, but also to make decisions, right? And sometimes it's good to have information about different formats and be open about this as well, not just say one is better than the other, because often it's not. No, I'm not saying always, but often. So it really depends on the purpose. Cool. Any questions after my long waterfall-y talk? Non-agile talk. No iteration there. Well, you survived. That's good for once. I sense the excitement. That's always good, right? So it makes me leave the room in high spirits. So thank you very much for giving me that vibe. Yeah, I mean, on the other hand, there's no magic there, right? It's relatively clear, the key aspects, but think about the features, what's available, and so on. And consider perhaps using some of those or trying stuff in your projects. I believe Marsh will release eventually the project specifications or assignment 2 specifications. And they are, I think, in the nature of an open-ended, more or less negotiated project. And you may just want to try out stuff like that, right? So, I mean, Protobuf, for example, on Android could be an option. You know, so, or if of relevance, or try validation, perhaps validation JSON schema. See and gain some experience, see how it goes and how it actually works. Yep, cool. If there are no more questions, then we leave it at this, and we'll see each other again next week, I believe. Good luck with the assignments. Hope you make more progress. Next week, I think we talk about testing. That's right.